In this video, I am going to talk about essentials of significant figures and the knack of rounding numbers. To determine how many significant figures are in a number, we have to follow the rules. Rule number 1. All non-zero digits are significant. Example 942. Here all digits are non-zeros. So we have to count all the digits. 1, 2, 3. Therefore, 942 has 3 significant figures. Let's take one more. 2, 3, 5, 6. All non-zero digits are significant. So here we have all non-zero digits. 2356. It has 4 significant figures. Rule 2. All zeros between non-zero numbers will be significant. For example, 1, 0, 0, 2. Here zeros lies between two non-zero numbers. We have to count all the digits. 1002, it has 4 significant figures. In 704, 0 lies between two non-zero numbers. So as per the rule 2, all zeros between non-zero numbers will be significant. So you have to count all the digits. So 1, 2, 3. So 704 has 3 significant figures. Rule number 3. Before knowing rule 3, we need to know about what are leading zeros and trailing zeros. Let's see some examples for better understanding. Leading zeros are the zeros in front of a non-zero number. Trailing zeros are the zeros after a number. For example, here in front of a non-zero number, that means these two are leading zeros. After a number, this is trailing zero. In another example, here in front of a non-zero number are leading zeros. After a non-zero are trailing zeros. In between non-zero number is capital zero. Now go to rule 3. Leading zeros are not significant. What are the leading zeros? Leading zeros are the zeros in front of a number. So this is your number 521. So in front of you have zeros. So this is called leading zeros. As per the rule 3, leading zeros are not significant. Because of that, you should not count these two. So for this number, that means 0.0521 has only 3 significant figures. 0.062. So this is your number. In front of you have zeros. This is called leading zeros. So leading zeros are not significant. So you should not count these two zeros. You have to count only non-zero numbers. So 0.062 has 2 significant figures. Trailing zeros for a whole numbers that ends without decimal point are not significant. Here you have trailing zeros. As per rule 4, trailing zeros ends without a decimal point are not significant. You should not count last two zeros. So for this 500, you have only 1 significant figure. Rule number 5. Trailing zeros to the right of the decimal place are significant. In this number, you have trailing zeros and decimal point. As per the rule 5, trailing zeros to the right of the decimal place are significant. So in this case, we have to count these numbers. So 1, 2, 3, 4, 5. So 12.000 has 5 significant figures. Another example, 500.0. A trailing zero when it is countable if it has a decimal point. 1, 2, 3, 4. So 500.0 has 4 significant figures. Let's practice few more examples using these rules. The first number 38.20. Here you have trailing zero and with a decimal point. If a trailing zero with a decimal point, it is countable. So you have to count the zero also. So count all the numbers 1, 2, 3, 4. So 38.20 has 4 significant figures. Check another problem. Here 2090. So 2090 has 1 trailing zero, 1 capital zero. The trailing zero with a decimal point, it is countable. The trailing zero without a decimal point, it is not countable. So it is not significant. So in this case, you don't have decimal point. So you should not count end of the zero. So you should not count the trailing zero. It has only 3 significant figures. Here we have decimal point, we have trailing zero, and we have captive zeros. As per the rule 2, all zeros between non-zero numbers will be significant. So you can count all the digits. So 1, 2, 3, 4, 5. So this number has 5 significant figures. In this example, we have leading zeros and captive zero. As per the rule 3, leading zeros are not significant. So you should not count these 3. You should count only 5, 0, 2. So this number has 3 significant figures. Now we will see rounding numbers with examples. 64.839906, nearest whole number. Observe this number. Here we have 64 is a whole number and remaining are in decimal places. They are asking nearest whole number. So we have to take only the whole number, which is 64 here. So in 64, we have to observe the units place. So this is the units place. We can call it as a last digit. This is the number we have to round up or down. To figure out, you have to look at the next digit, which is 8 here. So we can call this is a decider. If the decider is 4 or less, keep the last digit same. If the decider is 5 or more, you have to round up the last digit. So here 8 is our decider. Our decider is more than 5. So you have to add up the last digit. Here 4 is the last digit. When you add up, it becomes 5. So your result is 64.839906 is the result is 65. So this is the nearest whole number. If you like this content, please subscribe to my channel to get more interesting topics in future. I will explain another example. 64.839906, one decimal point. They are asking one decimal point. We have to check in decimal number, which is 8 here. We can call this is the last digit. So this is the number we have to round up or down. To figure out, we have to look at the next digit, which is 3 here. So we can call this is a decider and 8 is your last digit. If the decider is 4 or less, keep the last digit the same. If the decider is 5 or more, you have to round up the last digit. In this case, our decider is 4 or less. Keep the last digit the same. So that means 64.8. 64.8. So this is your one decimal point. 1.0763 significant figure. Whenever they are asking the significant figures, you have to count with non-zero numbers. Here 1 is a non-zero number. You have to count from left to right. They are asking 3 significant. So this is 1, 2, 3. This is the number you have to round up or down. To figure out, you have to look at the next number, which is 6. 6 is our decider. Then 7 is our last digit. If the decider is 4 or less, keep the last digit the same. If the decider is 5 or more, you have to round up the last digit. Here our decider is more than 5. So we have to round up the last digit, that is 1.0. When you round up 7, it becomes 8. So this is your result, 1.08. 3 significant figures. In this problem, you have leading zeros. In front of a non-zero, you can call these zeros are leading zeros. So you have leading zeros. So the question is 0.00236, one significant figure. So where you start to count the significant figure, leading zeros are not significant, so you should not count the leading zeros. You have to count from 2. That means this is your last digit. And to figure out, you have to check the next number, which is 3. So 3 is your decider and 2 is your last digit. You are keeping the last digit the same because our decider is less than 4. So this is your result. Here you have 3.185, 2 decimal point. They are asking decimal point. So decimal point is here, after means 1, 2. So 8 is your last digit. To figure out, we have to check the next number, so which is 5 here. So 5 is your decider. So in this case, your decider is 5 or more. So you have to round up the last digit. 8, you round up to 9. So that means 8 becomes 9. So 3.19 is your 2 decimal point. This is your result. Here the number is 4512. 3 significant is 1, 2, 3. Here this is the 3. This is the number you have to observe it. You can call it 1 is your last digit. To figure out, you have to observe the next number, which is 2. So now we can say 2 is your decider. If the decider is less than 4, keep the last digit same. So that means your number is 451. Just keep this 0 here. Now one significant figure. So you have to count the number, first number, that you have to count the number 4. So this 4 is your last digit and the next number 5 is your decider. So here decider is equal to 5. So you have to round up the last digit. When you're rounding the 4, it becomes 5. So for the one significant figure, 5, 1, 2, 3. So 3 zeros. 1, 2, 3. So this is your one significant figure. Here 0.004031. So you have to write in 3 significant figure. Asking 3 significant figure. For that you have to count with from a non-zero number. So this is your non-zero number. You have to count from 4. So 1, 2, 3. So now this 3 is your last digit and 1 is the decider. 1 is the decider. So if the decider is less than 4, keep the last digit as same. So for that 0. The result is 0.00403. This is your result. 0.007504. They are asking write in 2 significant figures. For the significant figure, you have to count from a non-zero number. So here 7 is a non-zero number. You have to count from here. So 1, 2. Now 5 is your last digit and 0 is your decider. Here 0 is less than 4. That means keep the last digit as same. So the result is 0.0075.
Your support means the world to me. Subscribing to my channel gives me the energy to create more content like this.